the velocity of electron in the first Bohr's orbit is 2.17 into 10 to the power 6 meter per second. Calculate the number of revolutions that electron makes in, I'll make it that electron makes in the third orbit of helium ion. What we need to find out here, the number of revolutions, right? What all we are having here? We are having the velocity in the first orbit. We want to calculate the number of revolutions. First of all, students, it should be very clear to you what you want to calculate, what all are the things given and what you want to calculate, right? So, we need to calculate the number of revolutions that electron makes in the third orbit of helium ion, He+, right? If it's 2+, there won't be any of the electron. So, of helium ion. Now, what is the formula for number of revolutions? Do you know? The number of revolutions is equal to the velocity of electron, and that is divided by the circumference. And that has to be divided by what? Divided by the circumference. Right? Circumference means the circumference of the orbit in which the electron is there. Now, first we need to find out. Now, what we know here? We know here that the velocity of electron in first orbit is 2.17 into 10 to the power 6. So, what we need to find is the velocity of electron in third orbit. So, in the previous question, I gave you the general formula. That is, Vn is equal to V0 into Z upon N. So, the velocity in the third orbit will be equal to 2.17 into 10 to the power 6 into Z, that is helium, Z is 2, divided by the third orbit, that is 3. Now let's find out the velocity. It is 2.17 into 10 to the power 6 multiplied by 2 divided by 3. So how much we are getting? It is 1.44 into 10 to the power 6 meter per second. So we have got one thing. Now students, this is our first thing over here. Now the second thing, what do we want? We want the circumference. Of what circumference we want? We want the circumference of the third orbit. Now what is the formula for circumference? It is 2 pi r. Now what r should be here? It should be the radius of third orbit, right? So, what should be the radius of the third orbit over here? R is equal to 0.529 into n square upon z. So, here your R will be equal to 0.5. Now students, this is in angstrom. 529 into n is the third orbit upon, what is the atomic number of helium? It is 2. What we will get here? It should be 0.529 into 9 divided by 2. What we will get? We will get 2.38 angstrom. Right? Now, let's come to our question. What is asked? The number of revolutions that electron makes in the third orbit will be equal to, what is the velocity? The velocity over here is 1.44 into 10 to the power 6. So it would be 1.44 into 10 to the power 6 meter per second. And what is the radius over here? The radius is 2.38 into 10 to the power minus 10, and that is equal to, let's calculate, it is 1.44 into 10 to the power 6 divided by 2.38, and that is into 10 to the power minus 10. And that will be how much? It will come out to be 6. Are you getting 6? Are you calculating? It is 0.60 into 10 to the power 16 revolutions. That is into 10 to the power 15 revolutions, sorry. It should be 15 revolutions per second. Per second. Right? So what is your answer? The answer would be, the electron is making how many revolutions? 0.60 into 10 to the power 15 revolutions per second. Right? So this is the way how we need to calculate. So students, these all questions are actually simple. You just need to put the things in place. How to calculate? First of all, what you need to find is, what you need to calculate is the first question. The second thing is, go for what all other things given. The third question, relate the formulas.